So exponents and problem solving, no different to equation solving when we're doing algebra, like linear equations, but we've got exponents. And so we've learnt that to remove addition, we do the opposite and we subtract. To remove multiplication, we do the opposite and we divide. To remove a power, what we do is we take the root of it, or think about it putting to the power of 1 over. So what I mean by that is if I have a cubed equals 27, to get rid of that power of 3, I put it to 1 over 3. So whatever I do to that side, I have to do to that side. So a equals 27 to the power of third, cubed root of 27, or you might actually know that the answer is 3. 3 times 3 is 9, 9 times 3 is 27. But the key here is you put it to the reciprocal power. So if I knew that a to the 1 over 5 was equal to 2, then to find a, I'd put both sides to the power of 5. 1/5 times 5 is 1, so I'm left with a equals 2 to the power of 5, which I can evaluate. 2 to the power of 5 is equal to 32. Okay, the trick is to remember that when you have even roots, you're going to have 2 solutions. And the reason for that is if I have that a squared equals 4, and I put both sides to the power of a half, because that's what I do, I just learnt that, I might say, well, a is equal to 2, because 4 to the power of a half, or the square root of 4 is 2. But it's actually equal to plus or minus 2. Remembering, negative 2 times negative 2 is positive 4, and 2 times 2 is positive 4. So whenever you have even roots, just remember that. So let's solve some problems. We have square root of x equals 9, so I can think of just squaring both sides. I personally like to, with these ones, always change to the fractional exponent because I think it works in the majority of cases. So I always like to do the same method all the time. So x to the half, so I'm going to square both sides. Half times 2 is 1. So I've got x equals 9 squared is 81. I just find that's a lot easier to get in your head on what to do. In the next one, I need to get rid of the negative first, so I'm going to move it to the other side. So it's like multiplying both sides by negative 1. And then to get rid of the 3, the power of 3, I have to put both sides, oops, that should be outside the negative, so both sides to the negative a third. So remember, brackets are important. So the 3 times a third is 1. So I'm left with y equals negative 27 to the third. Now, again, you can go to your calculator and do this, but I like to explain why things happen so you can try it and visualize it. Don't get too caught up though. 27, if I think about prime factors, is 3 times 9 and then 3 times 3. So I could rewrite 27 as 3 cubed. So it's a negative there, and that's all to the power of a third. 3 times a third is gone, so that's why my answer is negative a third. Oh, sorry, negative 3. Next, we have y to the 2 over 3 equals 6. So to get rid of that power of 2 over 3, I put it to the reciprocal, which is flipping it, 3 over 2. So y equals 6 to the 3 over 2. There's not much more I can do with that. You could split it up and say, okay, 6 to the power of 3 and it's the square root of that, but it'll be fine to leave your answer like that. Next one, we have this 8 with the x, so I need to get rid of that first. So I'm going to divide both sides by 8. So I've got x to the negative 3 equals 8 squared divided by 8. Using our exponent rules, I subtract powers. So 2 minus 1 is 1, so it's just 8. Then I have to put both sides to the power of negative a third, the reciprocal of negative 3. So negative 3 times negative third is positive 1. So that leaves me with my x, and then I have 8 to the negative a third. Now 8, you will get used to these prime factors, by the way. 8 is 2 times 4 2 times 2. So I can rewrite 8 as 2 cubed, and then that's all to the negative a third. So that's 2 to the negative 1. If I always want to express with a positive exponent, x is equal to 1/2. And you could do that in different ways to get to the same answer. So for example, I could have gone 1 over 8 to the third first, like changed it to the positive first. I've just left that to the end. Next, so I can't touch this 4a squared until I get rid of that minus 9. So I'm going to add 9 to both sides. So I have 4a squared equals 9. Now I need to get rid of the 4. So I'm going to divide both sides by 4. So I have a squared equals 9 over 4. I now have to get rid of my power. So I'm going to put both sides to the reciprocal, which is 1 over 2. So that means a equals, this one's straightforward because the power of half is a square root, so you can just think it's the square root of 9 over 4, which is 3 over 2. Note though, remember my previous mention that if you ever have an even power, which we do have, then my answer is always going to be positive and negative. Okay, so be careful of that. So it's sometimes worth highlighting. It's the one thing that people get wrong, usually lose half a mark in a test because of it. My other approach might have been from here to goes 9 is 3 squared, 4 is 2 squared. That's both to the power of a half. Again, it's positive plus or minus. 2 times a half, that's 1. So I'm left with 3. 2 times a half is 1. So 3 over 2. So either way works. Okay, now with the next one, note that we have an even power here. I'm talking faster than my computer can process. But anyway, so we've got an even power, so I'm going to have plus or minus when I move it. So I've got x plus 1 all squared equals 16. To get rid of that power, I'm going to put both sides to the power of a half, and it's plus and minus. So I'm left with x plus 1 on this side, because 2 times a half is 1, equals plus or minus 16 to the power of half, or square root of 16, is 4. I'm now going to split x plus 1 equals 4, or x plus 1 equals negative 4. Take 1 from both sides. So x equals 4 take 1 is 3, or x equals negative 4 take 1 is negative 5. And you can check as well with all of these by plugging back into your original. So here's x plus 1, 3 plus 1 is 4, 4 fours are 16. So negative 5 plus 1 is negative 4 all squared, positive 16. So I can check my answer. Next one, rewrite it. Cubed root of x plus 7 equals 4 cubed root of x plus 16. I'm going to highlight where I'm going to keep things. So that 4 cubed root of x is the biggest one, so I'm going to leave it there, and I'm going to leave the numbers on the left-hand side. So that means I have to get rid of whatever's not highlighted. So I'm going to take away cubed root of x from both sides, and I'm going to take 16 away from both sides. So that's gone, and that's gone. So I'm left with 7 take away 16 is negative 9. Equals 4 cubed root of x minus cubed root of x is 3 cubed root of x. I now have to get rid of this 3 because I can't get to the x until I do. So I'm going to divide both sides by 3. So negative 9 divided by 3 is negative 3. Change colour. So negative 3 equals, and instead of writing a cubed root of x, I'm going to write x to the power of a third. So now you can see what I have to do next. I have to put both sides to the 3. Negative 3 to the power of 3 is negative 27, so that's x. And just touching, I'm not going to touch on the next bit, which is transposing formulas, just so you can see where exponentials come into this. If I have a equals pi r squared, and I need to isolate the r, then the first thing I need to do is get rid of the pi. So I'm going to divide both sides by pi. So then I have a over pi equals r squared. To get rid of the squared, I need to put both sides to the power of a half. And because it's an even power, it's plus or minus. Now, the trick here is this is actually the area of a circle. So the area, I can't, and r is a radius. So technically, I can't actually have a positive and negative answer, but I'm just showing it, okay? But it's measurement, and you might not even know that, so you wouldn't be expected to realise it. But it's measurement, so r can only be positive, so it'd be a over pi. Okay, I'm not going to do the other two, I just thought I'd touch on that.